Right, I want to talk about the size and the scale factor of fractals. So up here I've drawn a pretty famous fractal. It's called the Sierpinski Triangle. And I'm going to calculate both the size and the scale factor for it. This is our first stage. You get the Sierpinski Triangle by taking out the middle triangle, unshading it, and leaving these three. And then I keep doing the same thing over and over again. Now the size refers to the number of copies, is the way I like to think about it. So one way to think about this is the number of copies from one stage to the next. Doesn't matter which you compare, but they have to be two stages that are beside each other. So if I look at from this first to the second, if I look at this guy, imagine shrinking it down and seeing how many times I see it in the next fractal image beside it. So I take this, shrink it down, I see that same shaded triangle 1, 2, 3 times. So that is the size. You can also see it if you take this shape, shrink it down. So imagine you have to see this whole thing. I see it in a smaller image right here in the top and on the left and the right. So 1, 2, 3 times I see this entire shape. So the size of this is 3. The scale factor refers to the length, so how long something is. And again, it's going to have to do with shrinking. So imagine taking this shape, shrinking it down, and now it's this one. It takes 1, 2 of those to cover the same length from when it was just over here by itself. Again, take the shape, the first shape, shrink it down, and see how many lengths it takes to get across. 1, 2 is the scale factor. Sometimes you'll see these written as fractions over 1. So you might see it written as 3 over 1 or 2 over 1 as well. So either 3 or 3 over 1, 2 or 2 over 1. Let me do one more. This one is called Cantor's dust. Cantor's dust has to start with a line and then remove the middle third. So it looks something like this. It's called dust because it rolls away and goes away like little specks of dust. So the size of this guy, I initially see I have a line. I shrink that down and I see a line repeated 1, 2 times. So the size for this is 2, or you might see it written 2 over 1. The scale factor, remember, has to do with the length. So I know how many of these shapes it takes to get all the way across from left to right. So my initial shape is a line. I shrink it down and it's one of these. But I've got to measure the whole length from the beginning to the end. Remember, I cut it into thirds. So what Cantor's dust does is cut the line into thirds. So it takes 1, the invisible one, and 3. If we're measuring the length of a piece of paper, we don't stop and pick up and move the whole thing. We're going to go from left to right. We can't just ignore the middle part. So the scale factor for this is 3 or 3 over 1.